You have clicked on Advanced Edge Pairing Part 2. So we're going to take off where we left in Part 1, where we made the first 8 edges, putting 4 on top and 4 on the bottom, and then we left 4 to still put together in the middle layer, just like this. And so what we're going to do while doing this is using the flipping algorithm. And if you haven't seen that, that means you didn't watch the first part. But we're going to go through it again anyways, just so everybody has a clear understanding of what it does. So what the flipping algorithm does is it will take a whole edge like this and it will flip it upside down. So these two pieces will now be here with the orange on this side and the green on this side, and this yellow and orange piece will be down here with the orange on this side and yellow on this side. So I'm going to do that flipping algorithm here so I can show you how it's done. The flipping algorithm goes, if you're holding this piece on the right side, it goes R, U, R prime, F, R prime, F prime, R. And as you can see, just as predicted, it brings this and it flips it over, and we still have all 4 of our finished ones on top and on the bottom. So you can see that it doesn't do anything besides flip these over. So we're going to put this into use now. So as you can see, we have the orange and green pieces here. We need a third one. The third one is right here. So what we can do is bring the piece that it's the area that it's supposed to be in, because this needs to be here. So this is the area we're going to move underneath the piece. So when we flip this over, this piece will now be here. So when we realign our centers, it will come back with it. So that's what we're going to do. We're going to slice underneath the piece, apply the flipping algorithm, R, U, R prime, F, R prime, F prime, R. As you can see, it's put here now, and now we can slice back and it will put it in there for us. So let's take a look at another one. Okay, so here's a good one to spot. Every time that you see one that's already in place, like this middle piece, and then another one that's underneath it that's flipped incorrect, we can actually put that one in and fix this one at the same time. So we'll fix this whole thing. So we need to locate the piece that needs to be there, which is the other green and red, and we need to have it in the bottom slice here. And so let's look for it, and here it's in the top slice, as you can see. So we need this to be in the bottom slice. Now we don't need to apply the flipping algorithm to flip that over and it will be there. We could do that, but we could also just turn it over this way. And now as you can see, it is in the bottom, and we're not disturbing our tops or bottoms, because all we did was we replaced one full tredge that's already done with another full tredge. So if we want this in the bottom, we can just turn it upside down. So what we want to do is we want to put this in its place and apply the flipping algorithm. And what that's going to do is it's going to keep this in the bottom slice here, this piece. So as this comes out, this gets put in. We apply the flipping algorithm, which flips these over and puts them up here. So when we realign our centers, it will bring this back and align with these pieces. And I'll show you what I mean here. So we're going to put this underneath, slice. Now we're going to apply the flipping algorithm to this side. So R, U, R prime, F, R prime, F prime, R. And as you can see, it flipped those pieces up. So when we realign our centers, it is going to bring our piece in and complete our tredge once again. So again, here we are. We've got the same thing. We've got the middle and an incorrectly flipped piece. And here is the correct piece here. So what we can do is put this in its position, flip this piece over. So if we put this in and then flip the piece over, and then when we realign this, it'll bring this piece back to align with those. So it's the same thing that we did over here. So now it's in the top layers. So we bring it over, apply the flipping algorithm, and then bring it back. And as you can see, it fixed that. What we're left here is something we call a parity error. What that means is that we cannot fix this using any other ones because all the other ones are fixed already. So we need to be able to flip these over, and it may look to you as if the center one is flipped over and these two are correct, when what the actual reality of it is that the center is correct and these two need to be flipped over. So we're going to do an algorithm to show you. I'm glad this case came up because now I get to teach you the algorithm. And I'm also going to have the algorithm in the description box in case you need to come back to it and just read it later on, or you can write it down. So the way we hold the cube for this algorithm is we want these three pieces to be in front of us. This is our top layer, this is our F layer, and this is our R. This is how we're going to turn R as this double turn like this. This is going to be our L. And this is F. And this is U, of course. So we're going to hold it like this, and we're going to complete this algorithm. R2, B2, U2, L, U2, R prime, U2, R, U2, F2, R, F2, L prime, B2, and then R2. And as you can see, that took the parity out. And what it did is it just basically switched this one for this one and literally did nothing else to the entire cube. Another parity that you will run into is the same one that you can run into when you're doing the beginner's method of edge pairing, where this one needs to be swapped for that one, and you can't just bring it over because you have nothing else on the cube to replace it with. So this is another parity error. And how we want to hold this one is like this. So we have this piece here and these pieces here, and this piece needs to be swapped for this. So this is our F, or sorry, this is our U, this is our F, this is our R using both layers, and this is our L using both layers. And we want to have, like I said, the cube positioned just like this. And again, this algorithm will be in the description box that you can go back to at any time. And we want to perform this algorithm. L prime, U2, L prime, U2, F2, L prime, F2, R, U2, R prime, U2, L2. And as you can see, it took the parity out. Okay, so I'm going to go ahead and scramble up these last four edges again and show you one more example solve of them. Okay, so I've got another scramble here, and I purposely set one case up so I can show you what to do in this case. As you can see, we have an orange and white piece here, and when you hold the cube like this, the white faces to the right. And over here, we have another one, and on this one, the white also faces to the right. And over here, we have another one where the white also faces to the right. So technically, they can all be matched up together, just like this. But we don't have anything to replace it with. So what we're going to do is we're going to put an unmatched pair up here to replace it with. So what you want to do is, because these pieces exist in 3 of the slots, we're going to have to use this one where one of these pieces does not exist. And we're going to put that up, and we're going to bring in a matched pair. It's going to look like we're going to break this up, but don't worry, we're going to put it back. So what you want to do, like I said, is find the one that doesn't have any of the pieces you're working with and bring it up into the top layer, bringing in a matched pair. Now go ahead and align all of these pieces together. And what I want you to do is put this in the top layer and bring back down this. So we bring that up, we replace it with that piece, the unmatched pairs that we put up, and bring it back down. Now when we realign our centers, it's actually going to realign that, that piece that we brought down. So we realign our centers just like this, and as you can see, it did realign the tredge that we brought down. So in fact, what we did is we completed a tredge, but we put it up here, and the one that's actually in here wasn't the one that we worked on. But it is the same thing, we still get one done. So let's take a look. Here again is another way that we can see this. We covered that in the last one, but we're going to go through it one more time, where this piece is flipped incorrect for that, and we need the piece that belongs here to be in this layer. So we're going to have to put it in that layer, and I can see that it's in the bottom layer right now. So like I said, we don't have to do the flipping algorithm. We can actually just turn this over, because all we're doing is replacing 1 for 1 at the top and bottom. Now that it's in this layer, we can actually go ahead and align it over here, which kicks out this piece. So we go ahead and we bring this all the way over here, and we apply the flipping algorithm, and then we can realign our centers, which will bring this and match them back up. All right, let's see what we have left here. I see that we have 2 here and one piece here, which means we're going to have 2 here and 1 piece here because we only have 2 left. So what I'm going to do is the same case as the first one, where I'm going to slice this over top of this. I'm going to flip this over and then realign. And what that's done is it's built one of these. And as you can see over here, we're left with these two, and we want this one to be up here. And we're going to get a double shot with this. We're not going to have parity, and I'm going to explain why. The reason is because when you know that we have this case and you bring one of these in and we flip it over, and then when we bring this back, it aligns these 3. So we know we're not going to have parity here. And we know we're not going to have parity here because we can't have parity by having 1 flipped and 2 that are in. That's impossible. If this one is in and this is in, this one by necessity has to be in as well. So when we go like this and we flip these over, we're also putting this one in this position. So when we bring it back, not only is it continuing to fix this, it is going to fix that. So it looks complicated, but it's actually only one move. So what we do is we slice it just like this, apply the flipping algorithm, and slice it back. And as you can see, we have finished the 4 edges. And now you can go ahead and solve it like a 3x3. So if you want, and you don't know how to solve it like a 3x3, then click on the page anywhere, go back to the home screen, and click on Solve Like a 3x3.